All right. Ooh, okay. So we'll get started. We're going to do our day one review. Just as a reminder, some info about the test. 15 multiple choice. We got 45 minutes. I guess we'll start with questions. Let's mainly focus on the review sheet. Does anyone want to throw out something on the review sheet that stood out or a particular topic? And when you ask, we can easily just make another one up as well. Can we go over domain and range? Yeah, that's a good one. Okay, because a lot of people threw that out. So I'll go to the review sheet and we'll talk about that certainly. But just let's recap it just in general. So first of all, domain and range. When we're talking about domain and range, domain is going to refer to the x values that are what we call permissible, and the range is going to be the y values that are permissible. In other words, like what's allowed in this function, right? For lines, which is the graphs that pretty much everyone starts with, right? Linear functions. The domain and range of linear functions go on forever. In other words, it's eventually going to hit every single y value, negative to positive infinity, and it includes every single x value, negative to positive infinity. But as you learn more and more graphs, you start learning that certain graphs don't go on forever and ever, right? Um, let's take the parent absolute value function. A little shaky there. It goes on forever left and right. So the domain would be like negative infinity to positive infinity. But with range, remember, we're looking vertically up and down. The lowest it goes is going to be 0, and it hits 0. In terms of its height vertically, it's going to go on forever. So, like, we had that question in the quizzes was like, what's the range of this exponential function? When you're asked a question like that, consider what the graph looks like. But for exponential functions, let's add a third one here to the mix. We know that those hover above the x-axis without ever quite touching it, right? So we wanted to say, I believe the answer was 0 to infinity, not including 0, because exponential can't quite touch 0. Now on the review sheet, um, we had something like this. So domain and range of each function. So what I would do is maybe make a sketch of what this looked like. And you know what? Let me just skip to my answers. This way I don't have to write and talk. Okay. So these are what the solutions look like, but even if you check them out, they still might not make sense. Um, for absolute value, I have a little sketch here. Even though this question didn't ask me to, water break. I made a sketch of what this graph looked like. So I said, all right, I know it goes 5 to the right, our IHOP rule, good kind of side review, and then 3 down, right? Now, domain, I'm thinking left and right. This is going to go on forever, negative to positive infinity. The range, I'm looking like this. So when I say looking, I'm going to highlight just so you can see what I'm talking about. I'm like, all right, that's the lowest it goes. And I see up top, it's not going to stop. It's going to keep rising. So that's where the -3 to infinity comes into play. Exponential, once again, the x values are all good here. The x values are all good, right? Left to right, that's going to go on forever. The range, once again, has kind of a min cutoff again of, hey, it doesn't quite touch 0, but it hovers above it. So that's why we're using the parentheses. And then we had a line for the third one. The line is just going to go on forever in all directions, negative to positive infinity for both. The other side note with domain and range would be questions like number 5, and you saw something like this on the quizzes. When you're given a restricted domain, how do you find the restricted range? Just evaluate, plug in the 2 endpoints. So for this one, when they tell me this line goes between -4 and 2, I'm going to evaluate -4, evaluate 2, and I know my line is going to be bound between those two numbers, -3 and 9. Okay. So domain and range are kind of handled on a case-by-case basis. There's no one set way of saying, hey, the domain and range is always going to be like this. But just know the basics. Hey, domain refers to what? I almost said it backwards. Domain refers to x and range refers to y. It helps to either type it into y equals or make a sketch of it. This way you see the image in front of you. If it's a question where like there's not a graph, that would be a tip that I would suggest. And yeah, that's about it. That's everything I have for domain and range. Number 4, case of background. Yeah, you put a bracket for the absolute value because it touches 0. We don't put a bracket around the exponential 0 because it doesn't remember equal 0. All right, a lot of people are saying number 4, and then we'll do number 8. Oh, number 8, I guess we just did. Yeah. Were there any follow-up questions while we're still on 8 before we move on? Is there something still confusing about number 8 specifically? We'll do 4 after this. 4. Yeah, recursive 4 we'll do right after this. All right. So yeah, like there's not much to this. It's not like, oh, you got to do it. You got to do a lot of work. You got to do 20 minutes of. It's just like either thinking about what the graph looks like, making a sketch. For the most part, for our purposes now, like the domain is going to be negative to positive infinity. There are graphs that we learn, though. There are graphs that we will learn that do have a restricted domain without it being restricted. For example, like we're going to learn the square root of x. With square roots, if you know this already, you can't take the square root of negatives. So think about what that would do to the domain. Just as if you're like, oh, is the domain always going to be that? No. Okay. Thanks. Why are you sending my YouTube? Okay. For number 4. So number 4, and then I'll make one up. Oh, is this the same? Oh, it was almost very similar to the question on the quizzes. But the one on the quizzes started with a 1, I believe. So this is what sequences will be on the test. Number 4 I'm talking about. So this idea here is with recursive, you have to be told where to start. So this is saying, hey, the first term is 2. And then this is saying, let's translate this into English. This is saying to go, to find a given term. What does this represent again? Can someone tell me what that represents? It was slightly different. Yeah, the previous term. That's the previous term. Take the previous answer, square it, and then add 1. So I'm kind of writing it out and showing the process. You don't even have to do that. So you would say to yourself, all right, starting with 2, I'm going to square it and add 1. So 2, 5, 26, and then just taking that one step further, 26 squared plus 1. So yeah, in the quizzes, it was actually 26 because we're kind of starting a little bit further down the line there. All right, so let's try another one with 4 because that's like a good one I can make up quick. I think everyone can use a little practice with this. So we'll say, all right, A1 is 3, and this rule is going to be A sub n equals, ooh, okay, I got a nice one. Okay, try that one. And I didn't put a question. Let's find the 5th term. Find the 5th term. Let me just catch my breath here. Can we also go over? Yeah, this review is just going to focus on part 1. Part 1, yep. Okay, I think I'm pretty good with questions. You can keep throwing them out. I was a little overwhelmed, but most people were asking the same one. So we got domain and range. We got recursive. Number 7. What was number 7? What was the topic, Natalie, before I look? Rate of decay. Oh, yeah, that's a good one, too. How many people here? Wow, 37 people. People that have hands up, what's up? Maximus and Kyle?
I was just going to ask if we could. I was just going to ask if we could go over number 9, number 12, and number 14. I just have one really quick question about number 7.
Sure.
For number 7,
hold on, wait till we get to it. Sorry, I thought you.
Okay, sorry.
We're gonna do that next. Kyle, you maybe have it up by accident, Kyle. All right, Kyle's no longer okay. So let's start with this one. So if we're told a sub 1 equals 3, 15. If only he said that before. If a sub 1 equals 3 and a sub n equals 2 times a sub n minus 1 plus n. What is n here? What does n mean? When it says plus n, what does that mean? Anyone? What does n mean here? Yeah, so like when you're doing your like second term, let's say, n would be 2. The term number, yeah, exactly. So if you're doing A3, n would be 3. So that's going to change every time. So let's be careful here. If you remember when I do recursive, I kind of like to, not that you have to do this yourself, but I usually make it like somewhat organized. Usually I'll stack them. Okay, so a sub 2 is going to be 2 times the previous term. That's always going to be the same. 2 times the previous term. And then plus n, meaning in this first calculation, it's going to be plus 2. And this one is going to be plus 3. I'm going to fill this all out now so I don't forget. That's that connection. See how n and n are the same thing? Now I can't fill out anything else. I have to kind of chain my way through it. So we get 8. 8 goes in this spot. We get 16 plus 3 is 19. We get 19, that's 38, plus 4 is 42. And last but not least, we're going to get 42 times 2 is 84, plus 5 is 89. Someone let me know if I'm making a mistake there. Did we get 89? Cool, nice, okay. So yeah, that would be the extent of sequences. So you multiply it by the term number. No, we're not multiplying it by the term number, we add the term number. That's the plus n. There won't be any explicit stuff, that would be it. That would be it. All right, number 7, Maximus and a few other, Natalie asked number 7. Let's check out number 7 first. We'll talk about it. And then a quick question. Okay, rate of decay. Sharon and Renee, they were students in my magnet last year, create a function to model the weight of their pet Perry. The function is p of x, 200.88 to the x power. What is the rate of decay? So what does everyone's, not everyone, but what do most people say for this when we throw this question out? What's the wrong answer for this?
0.88.
Yeah, people say 88%, 0.88, just because that's the number they see. What's the actual answer?
0.12.
Not 0.12.
12%.
Yeah, 12%. I guess 0.12 is technically right. So let's talk about that. And there's a reason why people make that mistake when it's decay. If it's super obvious when it's growth. If it's growth that looks like this, it's hard to really mess that up because you see the 0.12, you're like, okay, 12%. But when you see the 0.88, it is common to make that error. What do I always say for these? It's what's missing from 1. So if that was 1, it would be 100%, right? So what you can do is say 1 minus 0.88 if you're having trouble, and you're like, okay, that's 0.12. And then just remember to make it a percent. Technically 12% and 0.12 are the same thing, but we traditionally, it will say like, what's the percent of decay or something. My phrasing here wasn't as exact, but it's just more traditional to make this into a percent. Yeah, somewhat, like what's missing from 1. So that's what I'm saying. You can take away 1 if it's larger, or if it's smaller, you could do 1 minus that decimal. Sometimes you can just do it in your head. You're like, okay, that's 12 missing from 100, so 0.12. Go ahead.
If it was a growth, would it be a decimal?
If it was growth, what do you mean? If it was growth, it would be like 1.1.
Oh, okay.
Yeah, for growth, it would have to be above 1. Growth is just a little bit more obvious because you can see the decimal. So like if it was 1.25, you see the 25% growth there. Decay, it's kind of hidden. 12% is not in this problem. So someone that's playing eeny, meeny, miny, mo during the test is going to be like, oh, it's not 12. I don't see a 12 anywhere. But if you know what's going on, you're like, oh yeah, it's 12% that's missing. Decay is really saying what was lost. Technically, what 88 means is like, what is this? He's losing weight, I suppose. Technically means he's keeping 88% of his weight. But what is he losing? 12%. You're not going to need to do lin-reg on the calculator, but do you mean expreg? Yeah, lin-reg isn't on this test. You might be thinking of something else. Okay, so we'll get to that, Grant. What was the next thing I said? 9. Okay, this is a good, perfect time. So number 9. Let's do this. I'm going to switch to my Oh, is that going to mess up the recording? Okay, maybe, but let's pretend it doesn't. Technical difficulties. Okay. So I'm sharing my calc. Can someone just give me a yeah if you could see the calculator?
Yeah, we can see it.
Okay.
We can see it.
Okay. So I'm looking at number 9 in the review. I'm just going to walk through the steps. You can see the buttons I'm hitting on the left if you do miss a button. So I'm going into stat edit. Oops, what is this? This is a good reminder because people usually make, I have to help them reset because they hit delete and they delete a list. If you want to clear a list, highlight L1, hit clear, and then when you go down, the whole thing is gone. That seems like you're like, why would you do that? But we're going to get to topics later in statistics where you're typing in like 20 values. So it's good to know how to clear. All right, so I'm typing number 9 in. It asked me to make a function through this table. I actually just published a YouTube video today as well on this topic. Okay, 2, 5, 8, 3, 2. Technically, I only need 2 points, but I'll type in all 3. Just be careful as you're typing in X and Y that they correspond with one another. Like, you can't just scramble these up. And then 1 million, wow. 1, 8, 8, 9, 5, 6, 8. Okay, double check. I always like to double check once I type them in that I, look at your table and look back at what's in the calculator. Okay, 0, 2, 4. Great, great, great. Okay. Can anyone tell us what do we do from here? What do we do from here? Stat.
Calc.
Good. Scroll to calc. It's not there. Not option 4. Well, he asked for, I think he meant xpreg. So linreg would be linreg, Grant, but that's not on the test. We would use xpreg, choice 0. Kind of hidden. Okay, hit enter, 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 and you get 18 times 18 to the x power. Okay? Yeah. Let me just go back to my iPad because I want to mention something with this as well. This is a good rewriting one. That's the other topic that some people are a little scared about, rewriting. Okay, so we got this. Right? Like this. Okay, so right away, this is a nice and easy one to rewrite. I don't know if I put in my answer key or not, but these have the same bases. So what we can do is actually add exponents. Now, usually questions like this will say like, hey, which of these is equivalent to this? Like we could have just, if this was not a multiple choice, there's nothing wrong with you writing this. Just be aware of that. It's not like, oh, that's wrong. It's not simplified. It's just kind of making it a step, taking it a step further by knowing how you can break it down. But one thing that I always suggest with those questions that say like, hey, here's an equation, which of these 4 are equivalent to it? You can do it by using exponent rules like this, or the other way would be type them all into y equals and see which table matches the one in the question. See what tables match. That's the best way to see equivalency. What else was I going to say? Oh, how to do this by hand. I'll try to do it very quickly. Well, yeah, because this takes a while. Okay, I can do it quick, I think. I did post a video on that today, though. Evelyn, I think, if you asked. So what you do is you take your 2 y values. This would obviously not be on the multiple choice, but take your 2 y values, substitute in your x values, and then you can divide one equation by the other. What is that? I usually put the larger y value on top. You get 324 equals b squared. Take the square root or raise it to the 1/2 power. Usually if that's like b to the 5th, you'd raise it to the 1/5 power. In this case, you could just take the square root. You're going to get b equals 18. Once you know whatever the b value is, go back up here, go back to one of your originals, substitute in, and then solve for a, and you'll figure out that a is 18 as well. So create two equations by substituting in x and y, divide one equation by the other, use reciprocal powers to solve for b. Once you have b, substitute back in to solve for a. How do you know that it's b squared? B squared divided by b to the 0, 2 minus 0 is just b squared. Yeah, don't get too hung up on doing this by hand. Multiple choice, just use the calculator. Multiple choice, just use calculator. If you want a more detailed video, I literally just posted one today. It's on my YouTube channel. Okay. Like, how did you get b squared? Substituting in the x value, substituting in the x and y values. Substituting x and y values. All right, other questions, other topics. Go.
For number 14, could you explain how you got, sorry, I said 14, right?
Mm-hmm. Yes.
Oh, could you explain how you were able to find out that it was a vertical stretch, more narrow, and it was reflected over the x-axis?
Sure. Get rid of that red thing. All right, it's not going away. All right, whatever. So 14 is just transformation. So let's break it down one thing at a time. The negative sign is just going to reflect it. Any number that's bigger than 1 is going to be a vertical stretch. We like to say more narrow or skinnier. Don't say that, but just so you can visualize that. So don't look at -3 as a whole thing. It's actually two things. The negative sign is reflecting it. The pure number that's out there is going to either make it skinnier or more narrow or more wide. If it's between 0 and 1, it's going to be wider. If it's larger than 1, it's going to be more narrow. We've got our IHOP rule inside, so this would be 5 to the left, and then the -2 is just going to bring it 2 down. Oh my God, Natalie cursed. Mr. Virouette is typing. 10, 12, 13, 14.
Mr. Rice, I do have one more question about number 14.
Right.
If it's absolute value, if that's an absolute value sign, doesn't it mean that everything inside that absolute value sign is positive?
Correct.
So why would it be moving to the left? Because unless I'm mistaken.
Because now a negative, think about if you were to plug in a -5 to that, it would be 0, right? So it's taking a parent function and it's sliding it. Again, don't think about where, oh, everything's positive, everything's negative. What it's really doing is saying, like, instead of starting at 0, now it's starting at -5. The parent function usually is 0, 0, right?
Yes.
Now that 0 point is going to occur at -5. -5 plus 5 is 0, right? So that's going to be the vertex, ignoring all the other transformations. Let's just say it was just the left movement, right? So that 5 actually moves it 5 to the left because -5 is going to 0 it out. Positive moves it to the left. Yeah, exactly. Okay? If it's blowing your mind thinking about it, don't get too hung up on it and just kind of understand the rule. But that's why that happens.
Okay, thank you.
No worries.
Mr. Rice?
Yes.
For the growth and decay, do I write percentages or leave it as a decimal?
For your girlfriend? What did you say?
No, I said for decay, decay. Like, do I leave as a percentage or as a decimal?
Percent. We always do percents.
Oh, okay. And also, I have another question. When I press graph, nothing comes up on my calculator. Is there any way?
Try Zoom 6 or otherwise just reset it.
Zoom 6?
Try Zoom 6. If that doesn't work, do the reset, which you could stab the back of it, or do like second plus sign. Okay. Let's walk through 11 quick because this is a nice, easy one to talk about, and then we'll look at 12. 12 is that rewriting that we all hate. So with 11, how can you tell if something's linear or exponential? Linear is going to be something where we could tell it's a constant rate of change. Exponential, we're looking for more of like something where we're multiplying by something, doubling, tripling, or percents are another dead giveaway. Percents are multiplying even though we might think it's constant. For example, if I say, hey, I make 5% interest at the bank, just because it's 5% doesn't mean it's constant. 5% means multiplying by 1.05. So Chris triples the amount of cards, exponential. Tripling is multiplying by 3. Kamari gets $18 an hour. That's a constant rate of change, linear. Alton's Pokemon cards become 2% more valuable. Percents, exponential. Oh, I didn't even mean to do that, actually. That's funny. Constant rate of change. Wait, constant rate of change. Why did I do that? Times 1.02. Sojin exercises for 40 minutes, and then she's going to spend half the amount of time. Half the amount of time means multiplying by 1/2, so that's exponential. You don't want to get a question that's kind of like on the simpler side like this wrong, so just really make sure you understand the difference between the two. Okay, 12, rewriting. So this is the one where obviously I prefer if we know ideally how to rewrite, but you can use the calculator to check. Equivalency means they are the same thing. They look the same. They look different, but they're really the exact same thing. They look different, but they're really the same thing. Okay? So typing them in y equals is a good way to test that. Type them all in y equals. I mean, it's choice. So you have 4 choices and the original. So you're going to have 5 things typed in. I would type the original one up top, and then you're going to see which of those 5 choices matches, which of the other 4 choices matches with that top one. But on this one, we'll focus on how to actually rewrite. So one thing I can do here, I see 2 to the x power. I could do something there because there's nothing that can be done with 10 and 3. What I can do with that 2x is I can slide the 2x. Oops. I can slide the 2 inside, not breaking any rules. Why am I allowed to do that? Because this double exponent going forward would be 2 times x or 2x. So I'm kind of like taking it a step backward. I'm taking a step backward. Now that it's 3 squared in the parentheses, I could do this. All right. Sometimes we play around with that number in front, but there's nothing I could do with 10 and 9. If it was like an 18 or another 9, I could do something, but there's no connection made between the two here. Okay. What can we do with g of x? In g of x, the exponent kind of stands out to me. Let's go to my answer key here just to save some time. So what we can do here, why did I rewrite it like this? Can anyone tell me why I was allowed to do this? What I just underlined in red, why am I allowed to do that? Why are we allowed to do that?
Because the plus 10 in the exponent.
Mm-hmm.
And it's also the same base.
More specifically on like why I'm allowed to. It helps to think going back, going like forwards now of like, all right, we have this, how can I go to here? This is applying the first exponent rule you learn. You know this rule, right? It's kind of like deconstructing it. So it's like, all right, we have x plus 10, so we could break that apart where one base has an x, the other base has a 10. And what I meant going forward was like, now you could keep the base and make it x plus 10. So it's kind of like deconstructing that multiplication rule. And it's silly, but like who would ever do that? But we're just noticing the equivalency between them. What did I write? Exponent rule. So yeah. You could, if you want to take this even further, you could say, all right, what is 0.95 to the 10th power? Let me multiply that by the other number here. These are just the things you can do. All right, other questions?
Can you only do that if it's the same base for the B part B in question 12?
Yeah, but you know it's going to be the same base because it's saying 0.95 to the x plus 10. Like for example, if I had 3 to the x plus 2, I could rewrite that as 3 to the x times 3 to the 2. You know it's going to be the same base, right? Because you're breaking it apart. It's going the other way that you're like, oh, it only works if they're the same base. Does that make sense? Yeah.
Wait, just to clarify, so it won't work if it's not the same base?
No. but I'm saying there's no different base here. But yeah, this rule only applies if it's the same base.
Okay,
Exponential is a pattern of multiplication. Linear is a constant rate of change. Multiple choice is all true or false? There's no true or false. I'm not sure what that means. So yeah, it's all multiple choice. I don't have any carrots today. Maximus, go bud.
This is not about the review sheet, but how will you be sharing the recording of the extra help that's going on right now?
It's going to be, I have a friend that works for Fox, so if you tune into the news at 10 p.m., it's going to be on Fox Live. No, it's going to be on YouTube.
And your YouTube channel is RiseSpan67, right?
Yeah.
You're very creative with the usernames.
Okay. Let's take a look at quizzes if there's no other. Is there anything with quizzes? I know some of the, because this one, like the review sheet's good and the review sheet covers everything you'll see, but this actually had multiple choice. That's why I was, it was so, why I was stressing to kind of get it done. I wanted you guys to see at least all the different questions here. Let's look at something like number 7. Yeah, that one too. What was that one? Oh, that was the next one, number 8. Okay, so for number 7, we spent a lot of time on this last week. I think people are still confused of like, how come you kept it a of 4? Why didn't you do something else? I like to say, look at the x's. See how that says b of x and a of x? There's no change. So you're going to find a of 4. Now, had this question said this, let's change the question a bit. Had it said this, now instead of b of 4, we would find a of 8. So that's the one where you change what you plug in. But in this case, you should have plugged in a 4, kept it the same. So plug in a 4, you got 10, and then you change it after the fact. You take that answer of 10, and now you're like, all right, times 4 plus 1. What did he say? Yeah, what does that mean about my test questions? My test questions aren't unique. For number 8, so this one I would do xreg. This one I would do xreg. There wasn't, we'll go to the review sheet where you change it, but there's nothing on quizzes where you have to. If you did xreg, I'll skip to the, cut to the chase here. If you did xreg, you got this. So I think some people panicked and they did the thing with like, choose the closest one, right? That's not the answer. So this one was obviously rewritten. It was kind of like that enhanced version. 125 is actually a power of 5. 125 is a power of 5. So you could write it as 5 cubed. And now you have 5 cubed times 5x, 5 to the x. Keep the base the same and add the exponents. But you didn't even have to do this. You didn't even have to go to this extent. What could you do here? Type in the 4 equations, the 4 functions, and see which table has those values. There's only going to be one table that has all 3 of those values. Ethan in 723, I'm not even sure if he's here, but he said he just chose like this row and he plugged them into each one. And he only got, obviously the answer here is B. B was the only one that worked. That's another strategy as well. What if you don't have a calculator but it's coming in the mail? You could use like Desmos. That's why it isn't C. Yeah, it's 5 to the x power. It was never 25 to the x power. Yep, I have a resources link on Classroom for that. Let's go back to the review sheet. So, yeah, number 2 is where you're changing an input. So if you want g of -2, you're actually going to find f of +6. Right? Look at the x values. Compare 2 and 3. That's why I put them right on top of each other. In number 3, the x value stays the same. In number 2, we have to change the input. So in number 2, we're plugging in a 6. And that's where we get 9 minus 12 or -3. In number 3, you're still plugging in whatever x value you want, you're given, -1. And then once you get an answer is where you change it. You're like, all right, now times 3 minus 1. So it's, do you do the alterations in the beginning or do you do the alterations at the end? Increasing, number 6, while I have it up here, increasing, you look for where does the function go up? Okay, so that would be between -2 and 0. We don't include those borders. We count them as neutral. Where is it decreasing? It's decreasing when it's going down, so that's between -3 and -2, and it's decreasing from 0 to 1. Decreasing. Decreasing, the function's going up. Decreasing, the function's going down. Increasing, the function's going up. Other ones, throw them out, throw them out. Kira, go ahead.
For this question, I don't really understand how to use the greater than / less than symbols. For some cases, you use the one with the line under it, right? How do you tell the difference?
So for increasing and decreasing, you're never going to say or equal to, because we're not, like this point itself and this point itself are kind of like neutral. It's neither increasing or it's like the transition zone, right? Between increasing and decreasing. So for increasing and decreasing, it's always just less than symbols, right? If it's domain and range, then you could have equal to in some spots. If a point is included, you can have maybe less than in some spots where it's not included. So it depends. For domain and range, it depends. I know that's not a great answer, but for increasing, decreasing, it's just, you're never going to put the equal to.
Mr. Rice.
Mm-hmm.
For the, I forgot what topic it's called, but it was like you first list out a function, and if it, like, for example, b equals a of x times 3, and then a of x equals something, and then a of x is a function.
Say it one more time.
Like, for example, like they first have a function like g of x equals f of x times 3, and then f of x equals another function.
Like number 2 and 3, we just talked about those.
Yeah, for those, can you list one where it was like, I think it was like g of x equals 12, and then like, I think that was one of the class examples, and then you do it of reverse.
Yeah, you're not gonna have to do that.
We won't have. Oh,
no.
we won't have to do that. Okay.
It just, I would be comfortable with like number 2 and 3. Yeah, I know what you're saying. So he was asking for the ones where you're like, you have to search for the input given the output. It would just be something like this. It would just be something like this. That was a good question. What else? What else? What else? That's pretty much it. If you're asked to write a function, it's multiple choice. Use xpreg. Use xpreg. But if you want to do it by hand, go nuts. 13. Zemo's out. Bye, Jerry. 13. Yeah, okay. So 13 I would do xpreg for, or watch this. I'm going to do it without a calculator. I'm going to do it without a calculator. You could see that the pattern is times what? What are we multiplying by in consecutive y values? These are consecutive. I can clearly see that. What are we multiplying by? Times 3, times 3. So b is 3. I already know b. I need the a value. I need when x is 0. So let's work backwards. If it was 2, 5, what would it be with 1? So instead of multiplying by 3, we're going to divide by 3. Okay, we're one step away now. I'm going to divide that by 3 again, or multiply by 1/3, and you get that y-intercept. So without even touching xpreg, we know that it's 5/9 times 3 to the x power. If you did xpreg, it's just going to say 0.5555 repeating, which is 5/9. You could hit math frac on the home screen to verify that. Can you include how to use the calculator functions we may need for the test or something? I can't remember them. What do you mean calculator functions? I showed you how to do xpreg. That would be about it. Where did you get 5/3? I multiplied by 1/3. That's the same as dividing by 3. Can we review the xpreg? Didn't we do that earlier? We did that earlier. I have some videos on that as well. And it would be 1 times because I drink a lot of water. But I still don't understand it. Okay. Okay, it's not much to get. So I'm going to clear out what was there, highlight the top, hit clear. Under L1, I'm going to type in my x values here, which in this case, I'm on problem 13, are 2, 3, 4, 2, 3, 4. And the corresponding y values are 5, 15, oh no, yeah, 5, 15, 45. Okay? Now, we're going to hit stat. We're going to scroll to the right for calc. We're going to hit 0 for expreg, exponential regression. And then we're just going to hit enter. That's it. So I'm not sure. It says 6 at the end, but it's just rounding. 0.555. Let's say I don't know what that is. I'm like, what is 0.555? I don't want to write that. Write down as many as you can. Not literally, but. And then hit math frac, and it will convert it for you. Like, oh yeah, it's 5/9. All right, Natalie. Hopefully that helped. Let me just go back to my iPad. Other questions? Go ahead.
If the table had an x value of 1 and like the the y values were being like multiplied by a constant multiplier, you wouldn't have to like do the larger value divided by the smaller value and then like do a times b to the x power and everything, right?
Right. You would never have to do that anyway. I mean, if we're talking about the multiple choice, because there would be no case where you'd have to like show your work or do it algebraically. You could always just do expreg. But yeah, what you're saying is like kind of like this one, like you don't need to go to that crazy extent. If you know, for example, let's say you know 1/8 is on an exponential graph and you know the pattern is times 2, you could just sit there and be like, all right, I know the y-intercept is 0,4. So yeah, sometimes you can obviously use like an easier method.
Okay, thank you.
No worries. Other questions? Go.
Did we already do 10?
No. So for number 10, this one I thought was pretty. Okay. For 10, so compare year 2 to year 4. So year 2 to year 4 means I'm going to evaluate 2 and I'm going to evaluate 4, and then it says like difference basically, how much more. So I'm going to subtract the 2. So I would recommend using the home screen. I mentioned this in class. Sometimes when you use y equals with like more of a decimal type function, it hides them. You'll glance at the table and it will say like 8.2, and you're like, oh, 8.2, and then you realize it's really 8.21, blah, blah, blah. So I would recommend using the home screen. And then to the 4th, okay, so you get like 15.24, 15.249, and 9.301, something, I would just subtract these and then look carefully where it says rounding. It says to the nearest hundredth. To the nearest hundredth, it's 5.947 or 5.95. Grams? Grams, yeah. All right. My chat is like dying. Okay, here we go. Other questions? Other questions? Other questions? Review sheet, I mean, we've covered everything. Quizzes. Going back to quizzes. Was there something else on quizzes?
Mr. Rice, can you like just show me an example of like the one I asked you? Because I just want to know how to do it in case like on like the regions or something.
In case I'm lying to you and it comes up on the test.
Yeah, in case.
All right, I guess. How would I have extra help tomorrow, Yusuf? Oh, tomorrow after school, you mean, right? I thought you meant for this test. Yeah, I will. I was gonna say, like, at 6 a.m. And everyone can try this if they want. Okay, try these two if you'd like. Doesn't it show our last name? No, it should just show my iPad screen. If it doesn't, I'll just cut it out. Yeah, I've done that before. I've done live videos before and it didn't do the chat. I'll see. Okay. So if we wanted to find g of 6, what would we find in terms of f? If we wanted to find g of 6, what should we find in terms of f? Negative 12, good. Now we could actually plug in f of negative 12. That would be negative 12 plus 3 minus 2. Absolute value of negative 9 is going to be 9. Minus 2 is 7. 7. Where do you get 13? Where do you get 13? Not sure where you got 13, but I'm missing something. Yeah, I'm not sure. He made it 12 plus 3. Huh? Oh, yeah. So you did positive 12. Okay. Yeah. How did I see that? So where does g of x equal 10? So for this, where I like to start is by figuring out where would f of x equal 10. So let's look at f of x. F of x is the absolute value of x plus 3 minus 2. Set that equal to 10. And now you can kind of solve this. So where would this equal 12? So there's going to be two answers. There's a positive 12, and then there's a case where we could get a negative 12, which becomes positive 12. So the two solutions for this would be 9. That would create a positive 12. And what value would create a negative 12 in the brackets here? Negative 15, good, Evelyn? So that's not our answer because that's what it was in terms of f. Now we have to go back to what would it be in terms of g. So instead of multiplying the input by negative 2, we're going to divide these inputs by negative 2. And our two g of x values would be g of negative 4.5 and g of negative 15 over negative 2 is 7.5. Those would be our two g of x inputs. Okay, this last one won't be on the test, but Kyle wanted an extra practice problem with it. Number 1 could be, like the first bullet point, yes. First bullet point, yes. Other questions? Other questions? Given restricted domains, plug in to find the range, recursive, keep plugging in the previous one to get the next one. With function notation, be extra careful. Use y equals, use your home screen. Sometimes we try to do these in our head. I know this happened to a bunch of people this morning, just because how many people got it wrong. You square -2 and you're like, oh, -4, and you get the whole thing wrong. Use y equals or use your calculator. In the grand scheme of things, number 1 is pretty easy. You don't want to make a mistake on an easier question. My man, there's been 15 questions on the test for the past week. I don't know how many questions are on the test. So 15 questions still, yep. And how much of this review sheet will be on it? Everything. So there'll be one extra question. I think this only had 14. So like one of these could be split into 2 different problems. Oh, that was very dark. 15 multiple choice and 5 written. 15 multiple choice and 5 written. It's all multiple choice tomorrow. Yep, it's all multiple choice. Yep. Yep. A, B, C, D. Yeah, I'll make if everyone takes it tomorrow and there's no hiccups or something, knock on wood, then I'll make it available like right after you take it. Anything else? Maximus, anything else?
No, not that I can think of.
All right, covered everything. Wow, that was quicker than I thought. Yeah. I mean, going back to like Lucas, well, everything, yeah. So everything you see here, like, so it would be a multiple choice version of it. So quizzes might be a little bit better, but like imagine question 13 being like a multiple choice. And there will be one extra question, obviously, because one of these topics could have, like, for example, I'm not saying this, but like there could be 2 number 11s, let's just say. Or like 2 questions like number 5 or something. I'm just making that up, but that's why there's a discrepancy there. But there will be 15. All right. Anything else, guys? That's it? All right. If you look over the quizzes, you look over this day 1 review, I think you guys will do very well. The quizzes, I did post this. I know I kept just showing this quickly, but I posted the quizzes solutions. These were not available during the day because other classes are taking them, but these are now up. So this would be a good thing to kind of, if you want to practice your multiple choice ability, maybe look at the blank version of this and kind of, you don't remember the answers at least, try the questions like, all right, I don't know how to do number 3, but let me see if, or that's a bad example. I don't know how to do, one of the harder ones. Let me see, like number 6. I don't know how to do it, but let me test it out like it was the test tomorrow. How can I use the choices to help me? So the quizzes, the blank one might be a good thing to look at.
I have a question. When are you gonna post the video on YouTube?
I'll do it right after this. It usually just takes a while. It takes a while to process. Were you here the whole time?
Yeah.
So is there a reason why you want the video? You just want to rewatch it?
Yeah.
Okay. You could like ask questions now, right?
I don't really need anything.
Okay. Yeah, that's it. That's everything I have, guys. Let me stop the recording.